examples. Pick up here. I want to explain something about hyperbolas. And actually, you can write this expression down, something like in the top of the paper. And the definition of the hyperbola is a set of all points such that the difference between the distances from that point to each focus is a constant. So this distance minus that distance, you get some constant. And it turns out it's always the same, not the same constant, but there's a rule for it, or formula for it. So look at this. We're going to try to figure out that rule. Now, to figure this out, I'm going to pick a different point, because if I chose this point in the hyperbola, that rule should still apply. It should be the same difference. But here I can figure out what it must be. All right, first of all, this is A, right, because that's the vertex. This is from the center to the vertex. And then this is C. Yeah. Thank you. Now, here's the deal. I'm trying to figure out what I need is the distance from this point to each focus, right? But I don't really have a name for this distance here. I'm just going to make up a name. I'll just call it Z, right, for that little part there. It really is C minus A, but I'm just going to call it Z. Now, that's one of the distances. What is this other distance from this point to the other focus? 2A plus Z, right? Starting. So 2A plus Z. So one distance is 2A plus Z. The other distance is Z. I'm pretty sure when you subtract them, you get 2A. Write that down. So that's what's true of every hyperbola. That not only is the difference between the distances to the foci, from a point to the foci, a constant, it always works out to be 2A. Okay? Now, I want to show you, I'm going to go back to ellipses and do something similar. But I copied and pasted and realized after the fact that I don't really need absolute values since the distances are positive, of course, and I'm adding, so it's never going to be negative. Now, so same principle. So for now, the addition, if you add the distances, you get a constant. That's what makes an ellipse an ellipse. That's the definition. So I'm going to do the same thing. I'm going to pick a vertex to figure out what that constant might be. So just watch. Now this is A. No, that's C. Sorry. C is distance to the focus still. A is all the way out here, right? I'm going to do the same thing. I'm going to call this distance between the focus and the vertex Z, just so I have a name for it. And so the distance from this vertex to that focus, the nearest focus, is just Z. How do I express the distance from this vertex to the other focus? Yeah, 2C plus Z, or Z plus 2C. Which, when you add it up, you get 2C plus 2Z, or 2 times C and Z. But wasn't that really just A? So it actually works out to 2A as well. So, which is nice, it's the same rule. On an ellipse, the sum of the distances works out to 2A every time. On hyperbola, the difference between the distances works out to 2A every time. By the way, a little nicer way to get there is when I ask for this distance to this focus, the way you could express it is that, first of all, that's 2A. All the way across from vertex to vertex is 2A. So it's 2A minus Z. You see that that's another way to express that same thing? Well, then if you do that distance, 2A minus Z, plus the other distance, which was just Z, it works out to 2A, obviously, that way too. All right, now let's do these. Once again, first of all, I want you to notice navigation was just the topic, so I would maybe circle that. Whereas it looks like it reads navigational ran, which doesn't make sense grammatically. So ran is the first word of the sentence, in other words. So we'll do this one first. If you read through it, you know that E is due west of F. So draw it like this. E is over here, F is over here. And I'll just tell you those are going to be the foci of a horizontal hyperbola. So I'm sketching a hyperbola. And by the way, we need to make an equation. We're going to choose to make the center, basically be the origin. That makes it much nicer than that otherwise might be. So this point is going to be 175 miles east to the origin. The other focus is 175 miles west of the origin because it said the distance between them was 350, right? Now, I'm going to put a point on the hyperbola. Put it wherever you want. It really doesn't matter. Try to put it nowhere special. Actually, I should be careful about this. It said that the ship is 80 miles farther from station F, which means I messed up. It should have been over on this branch, technically. Doesn't actually matter. But let's get it right. I'm just going to call one of these D1, the other one D2. It doesn't matter which one you call D1 or D2. And once again, if it's a hyperbola, then the difference between those distances is a constant. But if it says that the station's 80 miles farther, then that means the difference is 80 miles. We know that distance, that difference, always works out to 2a, so which means we know that a is 40. And we already knew that c was 175, right? So look, we're almost there. Let me start writing the equation. We know the equation is going to be x squared minus y squared because it's a horizontal hyperbola, centered at the origin. A was 40, so the first denominator is just 40 squared, which is 1600. But we have to calculate b squared. So b squared is c squared minus a squared, because once again, c is the biggest. So we'll just type it in. And frankly, you can figure out b, but we don't need b. We need b squared. So that denominator works out to 29,025. Just for the record, if I did find b, it works out to around 170 point something. All right, listen, we're done, but I want to do this thing typed in the calculator. Okay, the goal is to find the equation. That's the answer. To type this in, though, we need to rewrite this as y equals. So I'm taking this in a couple steps. I'm trying to get y by itself. If I ever have a coefficient that's negative, then what I prefer to do is just move that term over, just like swap these two terms. This moves over here, becomes positive, and that one goes there. Of course, you could move this over and swap the signs, has the same effect. Now to finish it up, we're going to have to multiply both sides by that denominator, 29,000 something, and then take square root. I'm going to write this out now. So it would be the square root of that denominator times what was sitting over here. And now we're going to type that in. First of all, make sure you're in function mode, so hit mode and make sure it's not in parametric or polar. And then go and clear everything out. And go to y1 and type that in. Square root. Now, we need to set the window. Horizontally, it goes to 175. Vertically, we said B was like 170. So I'm just going to go to make my window like -2 something. I did 200 in previous periods. I'll try 250, see how that looks. You can see, if you type that in, you only get the top half of the hyperbola. Watch this. I'm not going to type that whole mess in again. That'd just be painful. So do this. Hit on Y2, hit opposite of, hit the negative sign. Hit the variables button, vars, it's just left of clear. And then right over to Y vars, and then go into function mode and choose y1, because that's all we have, right? Is y2 is just the opposite of y1, and there you go. So once again, you hit bars, y bars, function, because we're in function mode, and then choose y1. So we're trying to do the opposite of y1. Because it really does a horrible job anytime the graph is close to vertical. So logs, it doesn't draw right usually. Some of them do better. The newer, they're getting better and better, but yeah, this one just does a horrible job. Because it should be a complete hyperbola, obviously. All right, I want you to try the other one. Okay, so try the first example. What did you do? Your window settings are just off. You're just zoomed way out. Well, I mean, it tougher doesn't look in, here. Do like I had it, negative 200, 200 for both. It still looks. What did I do? Try the next one. We'll see if we can figure out why it doesn't look the same, but should have closed this. Someone have a question?
Yeah.
Well, I mean, come on, look at it. I mean, look at the numbers in the graph. This focus is 175, so I'll make it, 200 something. 200. I think that's what I did. I had 250. That's why it looks different. So what? I'm saying, and then vertically, I'm looking at it. So it's, make it square. Just do 200, negative 200, 200 for the x min and x max and the y min, y max. What do you mean? Only see the distance from the center to a focus, right? The foci. I'm going to start working that one. If you're already working on it, try not to look. Try doing it on your own. If you're behind though, then you might just follow along. Same situation, but now you have one focus north of the other one. Once you get the equation, I want to type this one in the calculator as well. Yeah. All right, any questions so far? Once again, S and T that they gave you, those are the foci. Since they're 240 apart, then they're each 120 from the center. So that's where I got C being 120. watch this. This one's easier to solve for. All you need is move this term over, it becomes 1 plus that, multiply by 900, take square root. So what you'll be typing in is the square root of 900 times 1 plus this. So I'm saying, ideally, you just have this sitting on the paper, and you mentally rearrange it, so you just type in the calculator without having to do a lot of work on paper to get it typed in. So, like I said, I move this over, multiply by 900, take square root. And then adjust the window settings. Actually, the window settings, I think, will match nicely. I think they'll work for this one. Say again? Yeah. That's the beauty of it. Don't have to ever mess with that. Yeah. And I think it's kind of nice to be able to type it in the calculator. And actually, we're going to use it on the next example. Not just to graph it, but to find an answer to the question. Okay? Yeah, question? Because look, to get y by itself, I'm trying to get everything away from this, right? I get rid of this first, and moves over becomes 1 plus. And then times 900, and then square root. But I mean, initially, I moved this term over, so it became 1 plus. Yeah. All right. By the way, this last example with microphones, frankly, it's just an example of that involves hyperbolas. There really is not enough information to solve anything on that one. So it's just, that's all it is. We're not going to do it because it's not even doable. We are going to do this one. Read the lightning problem. All right, look up here. The very next, I already have the picture for you. And listen, if you lived in other parts of the world, I wouldn't expect you to know how long a mile is, but in America, that's our system we use. So a mile is 5,280 feet. You should really know that. Now, another bit of information you need that they didn't give you, and write this down. The speed of sound is approximately 1,100 feet per second. And, if you're at sea level with dry air, you get a more exact answer, but it's going to fluctuate depending on your altitude. The density of the air basically is going to affect it. And so that's good enough estimate of what we're doing. Okay? So look at this. And by the way, so it said it took it 1 second longer to get this way. Okay, I'm saying it said it took it a second longer for the sound to travel to this point than it did from this point. Or the other way around. It took it, the thunder is traveling this way. So it took it a second longer to get to here than it did to here. Now, so write this down. Therefore, the difference between the distances is, well, it's 1,100 feet per second times 1 second. I'm pretty sure it works out to 1,100 feet. But once again, on a hyperbola, that difference between the distances always equals 2a, which means we know a is half that. 550. C was the 2640, right? So, go ahead and figure out the equation for this hyperbola. Once again, you have to find b, really b squared, by doing c squared minus a squared. By the way, just before you do that, watch this. Once again, it's horizontal, and we're making the center be at the origin, so it's just x squared minus y squared. This first denominator, I'm just going to write as 550 squared. That's a squared. I don't care. I mean, that's easier than writing whatever that is when you simplify it, when you evaluate 550 squared. And then for b squared, we're just going to write it out. Yeah, we're going to write that whole thing, because you take square root of it, you don't get a nice number. So, yeah, we're just going to write that as our denominator. All right. There's our equation, but once again, that's not our goal this time. Our goal is to find the coordinates of this point on the hyperbola. Actually, before we get back to getting to working this, you actually know one of the coordinates for this point. Yeah, because it's due north, it must have the same x value as that focus, right? So listen, we could just plug that into the equation and just solve the equation, but I want to actually get this in the calculator, y equals like we did before, and then get the y value that way. So I'm going to rearrange the equation first. And so, once again, with this, the first thing I'm going to do is swap the 1 with the y term. You don't have to do it this way. And then, to finish getting y by itself, you multiply by that denominator and think square root. In fact, I'm just going to type that in. I'll write it down. A bit to write. And then once again, type it in. Our window settings will have to change this time, by the way. Let me get it typed in first. Yeah, be careful. Last period, I left a 0 out at one point and messed everything up. But if you look at our picture, I mean, you have to go at least 2640. I'll just make it 3000 both ways. And we should see the horizontal hyperbola. Once you have the equation typed in, then you could just go to the window and type it in. But if you put your calculator, you go to table set, put it in ASK mode, then when you go to the table, you type in your x values, and it'll just spit out the answers. And so you can see that was a nice check to see that it hits the vertex. And then when you type in 2640, you get the answer, the y value. And so that's our answer. That's where the lightning struck.